JEE Advanced 2022 had one bonus question. 2023 had two bonus questions in one paragraph, the famous chimney problem. But in 2024, possibly no bonus. Or probably. Anyway, welcome back to this video. Welcome back to the channel, and it's yet another video. So in this video, we will reflect about this problem, which is from JEE Advanced 2024 paper 2. Some of you might have solved this on this Sunday. Probably some of you got correct, some of you got wrong according to different coaching answer keys. But after I solved the physics paper, I have solved it, and the only question which could be bonus, which was closest to bonus among all the 34 questions of physics, was this one. Okay, I will show you how, and I hope you have already read the statement by the time I was saying blah blah. Sorry. So this is the question, and we have a magnetic field here, a circular loop of wire like this. This is mass m and radius r. We have an upward magnetic field V0, and we also have gravity. Okay, and we have to comment on the angle. So let me show you the side view of the system. So if you see from this side, this is your eye. Okay, I don't draw much good eye anyway. So if you see from this side, this will look like something like this, and this angle is theta. Okay, and this is the radius. So this will turn like this. This is a loop. Okay, loop like this. So and this has turned like this, and now this is in equilibrium. So anyway, and the radius is r. So this is the side view, the more important view from your point of view. Anyway, and let's draw the free body diagram now. Okay, so the free body diagram will look something like this, where this is the loop. Let me show you the loop here. Okay, this is the loop. This is circular loop of radius r, and this angle is theta. It has turned by angle theta by this PQ. Here we have a PQ rod. Okay, so anyways, and now the thing is that we have to comment on the angle theta. Okay, so we have two methods for this problem. I will show you one by one, and also we'll show why this should be bonus. Okay, and why it should not be bonus. There is also a reason it should not be bonus. Okay, so let's get started here. So we have a gravity like this, mg, and an upward magnetic field, and due to this upward magnetic field, this will also have a magnetic moment in the direction of its area vector. So the direction of its area vector is like this if you consider positive magnetic moment, and the direction of B0 is upward. So this is the kind of vector diagram, whatever you say. And this angle, if you calculate this, as this is theta, this angle will come out to be pi by 2 minus theta. Okay, so the torque due to this torque, which you can see over here, this torque due to this magnetic moment or magnetic field, whatever you say, this is m into B0 multiplied by our not sine theta. Yes, sine theta, cosine of pi by 2 minus theta, which is nothing but sine theta. Okay, and also now see this, when will this be in equilibrium? Obviously when the moment of the gravity will balance this moment due to the magnetic field. So we'll simply equate the two moments, okay, or two torques, whatever you say, because for equilibrium there should be no net torque. Okay, that's the concept of our rotational equilibrium. So that's the whole point of this question, and m here is nothing but I multiplied by a, which is pi r square. So this is nothing but pi r square into I B0 sin theta. Okay, and now what is our so this is equal to the torque due to gravity. So we may simply write that pi r square I b naught sin theta. And what is the torque due to gravity? This angle is theta, and this is our oh, I have made a mistake. I'm very sorry for that, because when you do cross product, this is you get a sine term outside. Okay, so the magnitude of a cross b is a into b sin theta. Okay, and so this angle is pi by 2 minus theta. So this should be cos theta actually. Let me rewrite that. This is cos and this is also cos. This is cos. And now what is the moment due to this gravity? The gravity in this side. So notice one thing, we have to calculate this moment about this point because this is hinged here. Okay, no other point will work, or it may work. Anyways, I mean, how other points will work, but here we have a hinge force actually. Wherever you have a hinge, you have a hinge force. So it's always better to calculate the moments at the hinges. Okay, so this distance into mg our will be our moment due to gravity, and this distance, if this is theta, this is r, this will be r sin theta. Okay, so our equation is mgr sin theta. This is equal to this previous thing. I mean, this is equal to this. So if you calculate tan theta from this, tan theta will be nothing but pi r into ib naught divided by your this is mgr sin theta, so only mg will remain here. So okay, so we have calculated a value of tan theta which matches with the A option, which was the point of view of this question. I mean, some of you might have solved this using, I mean, in this way, but there is a catch here, a small catch is here. Okay, so now let us think by another point of view. Let's think of energy conservation. Okay, mechanical energy must have been conserved here. So if mechanical energy is conserved, then I mean, right, this what was the, I mean, the what the increment of potential energy. What was that? That was nothing but okay, let me write energy method here because this is a different method. Energy method. Okay, so what was our increment in potential energy? That would be mgr into, and this angle is theta, so this will be nothing but 1 minus cos theta. Well, am I right? Center of mass is here. It had been here, somewhere here. So should there be a by 2 here? I think so. Okay, so this has been this. This is theta. This is no. There wouldn't be any, because this radius is r, not the length. Okay, so this is our increment of potential energy. Okay, and now we can we can say that it is equal to the energy due to the magnetic field. Okay, and what is that? Well, energy due to the magnetic field, in electric field you have P dot E for electric dipole. For magnetic dipole moment M, so here you will simply have M dot B. Okay, so if you go by this method, let's calculate this. This is 1 minus cos theta, so this becomes 2 mgr sin square theta by 2, and M dot B, so this side becomes just our, I mean, what we calculated, pi r square ib naught, and now this will be if you open this will be mb cos theta, and the angle between our magnetic moment and the magnetic field, it was simply our pi by 2 minus theta. So the cos theta will be replaced by sin theta. Okay, so now you know that sin theta is equal, sin 2 theta is equal to 2 sin theta cos theta. Okay, so from here we can write that if we take it this side, so there will be this 2 will get eliminated, and we will have tan theta by 2. It's just mathematics, that submultiple angle. Okay, if you do not know the formula, kindly go and see it. So tan theta by 2, this will be nothing but pi r square. No, the r square won't be there. This r and this r square, 1 r will cancel, divided by this 2 is also cancelled. So this is mg. Okay, so notice one thing. From this method you got tan theta is equal to pi r I b naught by mg, and from this method you got tan theta by 2 is equal to pi r I b naught by mg. So now tell me which method is wrong. Okay, none of this method seem to be wrong, right? So if you solve by energy, none of the options will match. Okay, you can see that none of the options contain tan theta by 2, and if you solve by your torque or moment balance, whatever you say, the first option will match, A option. Okay, so JEE Advanced the authority must have solved by the torque balance, whatever you say, and this was our energy balance. Energy has to be balanced, right? Because there is no other energy except this and this, the potential energy, mechanical potential energy, and the as it is at equilibrium, there is no, if it weren't at equilibrium, so let's suppose for a moment that this weren't at equilibrium, so you could not have written this equation to this torque balance. Why? Because there is some existing torque, right? It cannot be equilibrium if there's there's not any existent torque. Okay, so this must have been in equilibrium. So that's why the thing comes here, that the two different methods give two different solutions. Okay, so that's why the question becomes a little ambiguous, and also you may argue that it can be in motion still in equilibrium, so that's also a point of argument. But by your logic, we will never reach that these two, if you equate these two, this will give that tan theta is equal to tan theta by 2. Okay, which is not possible, not at all possible for any theta, in the range 0 to pi by 2. Okay, so anyways, so my only argument is that, so if it is not possible and there is an ambiguity, okay, so I would have accepted if anyone would say that this is in motion but still in equilibrium, but at the end of the day the question remains a little bit ambiguous. Okay, so that was the whole point of this video, that if you solve by energy method you get this, which is not an option, and if you balance the moments you get this. But the thing is, here you should have had an equilibrium. Okay, and if you tan theta is this, so this also denotes that the circular loop, it can never be in equilibrium, which is also not true, right? Because you have an energy and you have an opposing energy, equilibrium can never be there. Even at SHM we have equilibrium, so maybe it is unstable, but there is an equilibrium, right? So that is the whole argument. Okay, so I hope you understood. And there is a channel on YouTube, JEE Challenges by PW. So the channel has also posted the same argument on this same topic, and I found it to be very much interesting. So I thought that I should also make a video about this ambiguity. And so at last I'll say this is the only ambiguous question, but to be honest, I don't think they will give this as bonus, because they do not give free marks. It's JEE Advanced. Last year it was because that question was, I mean, too much ambiguous. So, but this question is not that much, because one method is giving you an answer, so I do not think this will be a bonus. Okay. So anyway, let us hope for the best. You can also challenge if you feel my logic is good, my or anyone else's. I mean, you should discuss it by your own logic too. Okay. If you do not get it, there is no meaning of challenging. Only you can challenge only when you get it. Okay. Because you will challenge and say that I said this, and there is no point, because I am not going to challenge. I do not have the money for that right now, at least. Okay. So anyway, that was again the whole point, and I hope you liked the video and got why this question is ambiguous. And anyway, thank you for watching. You can suggest me more questions of this year's advanced, and also if you have doubt in any other question, probably from any other subject. I mean, any one of you suggested me a question from chemistry, but the thing was that I had forgotten the reaction, so I have to revise a little bit. So anyway, so you may suggest anyway. Okay, so I will try to clear your doubt. Okay, so anyway, this, I mean, I again hope you got it, and that's the video for now. And at last, thank you for watching. We'll see you in the next video.